是我们的数据科学家，那个也是我们这个在 Downtown， 他是我们 Downtown 这个 Meet Up 主要的一个演讲者。然后呢，今天他跟大家分享一下，他来自台湾，然后他中文，你可以尝试说一下中文是吗？然后我没有听过他说中文 ，anyways。然后他可能是想今天他偏向于用英文给大家讲这个 data science 方面的这个 demo。我们会以这个天气数据，就是 weather data， 怎么在这个用 weather data 就走一遍，从头至尾走一遍，然后再看我们给大家，我们提前准备了这个 weather 的，就是可能是中国的吧，中国的天气数据。对，然后呢，根据中国天气数据是一个 CSV 文件，然后我们在这个天气数据上如何实现数据的快速处理以及可视化，在基于大数据条件下，好吗？好，我们欢迎这个。其实我可以理解他为什么他的中文不太好，因为他的太太是法国人，他在家不说中文，所以说他这个中文就越来越退化，越来越退化，就成今天这个样子。所以你可以努力一下啊，我免费给你 free session。谢谢。
Testing, testing. Can everyone hear me? Okay. Really sorry about not being able to speak in Chinese. 我会讲国语，我在台湾出生，差不多1岁半开始在加拿大长大，所以我的国语真的是没有说很好，所以需要解释的东西的话是一定要英文，所以不好意思 ，sorry 。Okay, so we can start off by talking about a little bit about data science, and we're all talking about the 3 core categories required for data science, and that is computer science, being able to program and be able to understand the architecture behind all of the programming features, math and statistics, and finally domain knowledge or subject expertise. Okay. So in data science, there's really just one kind of standard methodology that brings data scientists from a business problem until the very end to be able to solve that problem or be able to deal with some sort of solution regarding that problem. Okay? So starting at the very top left, we have some sort of business understanding. So every problem comes with you need to understand what the requirements of your company with regards to a certain problem. You know, do you want to understand your customers better? Do you want to be able to forecast your customers' behaviors better, and so on? So that can be your overall kind of idea as to how you want to shape your solution. Next is the analytic approach. So this is how you want to be able to deal with a particular problem. For example, if you want to better understand customers, perhaps you want to be able to group them. So to group them into different smaller subgroups and be able to address each of the subgroups perhaps slightly differently. And in that case, under analytic approach, you would consider cluster analysis or other types of ways in which you can segment your customers into different subgroups. Next, you want to understand your data requirements. Exactly, in order to cluster your customers into specific groups, what kind of data do you need on the customers? For example, their spending behaviors, their patterns in terms of how they behave, how much they spend, where they're from. So are they male or female? Do they have a small or large family? What do they typically like to spend money on, and so on. So that's kind of your understanding of what kind of data you need. Following that, you need to actually go ahead and collect your data. Now, this is where this is a little bit different from science. You can kind of see how starting from a problem or some sort of research problem, going on to perhaps a hypothesis and so on, this is very similar to a scientific method. Right? So for those of you who are coming from a scientific background, this is very similar to the science method. But what's different in science is, in science, typically we start off with a hypothesis. So we go into a problem knowing some sort of hypothesis. But when it comes to data science and big data, sometimes you already have a huge log of data, whether it's from a web log, whether it's from Clickstream, whether it's from weather. The data is already there. And from that data, you're trying to generate some sort of insight. So you don't know what you're looking for, but as you explore the data, you start to come up with questions that you want to ask with regards to the data that might help your company, that might help your research, So that might help your study of this data framework. After collecting the data, or if you have the data already, next is to be able to understand the data. So this requires exploring the data, perhaps creating some visualizations, kind of looking at averages or counts and so on, just getting a sense of the better sense of the data. And sometimes business intelligence kind of stops there, right? Or up until data preparation, business intelligence often kind of stop there. They kind of get a sense, overall sense of the data, but they don't create a model. Okay. So after understanding the data, sometimes you'll need to prepare your data. So often your data can be very messy. If you're trying to analyze, for example, doctor's notes. So when you go to the doctor, a doctor will write you a prescription, or they'll say, this patient has symptoms, X, Y, Z. Their blood test shows, X, Y, Z values, and so on. But it's often written down or it's recorded from a voice, so it's very unstructured. So in the data preparation stage, your goal is to try to clean all the data, put it into some sort of table or otherwise to make it digestible for the next step, which is to model your data, to create some sort of model to apply to your data or implement on top of your data. Now in data science, typically this requires machine learning, so it's creating some sort of statistical learning method in this stage. Now once you've created your model, you want to be able to know exactly how your model works. Is it actually able to predict how well your customers are spending money, or is it doing it very badly, right? So you want to be able to evaluate your model and then go back and forth. So if it's not doing very well, then you go back to create another model, maybe improve upon it, change the model, and so on. And then after you've decided on a roughly decent model, then you can go ahead and deploy it. And if you're in an environment in which you're trying to deploy the solution, maybe you put it on the website, create a recommender system, put it on a website, and see how it runs. Is it actually gaining money, or is it actually performing well? And from that, you can get some feedback from the real world. Okay? So this is kind of like the flow of data science as practiced by data science around the world. Okay? And as you can tell, it's very iterative. So even if you end with feedback, sometimes you might go back and you come up with another business problem. After having created some sort of model, you realize, oh, I'm missing this, or what if I could have done this? Then you go back to the first step and you continue and go in these kind of cycles. Now, one of the focuses in data science is kind of the tape was a little bit too weak there. So one of the focuses of data science is an understanding of all the algorithms needed to better understand your data, to better analyze your data. Okay? So there are multiple different algorithms that you can explore in this analytic approach step that you can present. And if you don't have this kind of toolkit of all these models that you know of, then how are you going to present your idea to perhaps a manager and say, oh, what if we did this to the data? What if we did this algorithm to the data, and so on? So there's lots of different algorithms and lots of different ways in which you can create a model to analyze data and to get some sort of insight from it. So as I said before, if you want to create subgroups of customers, that would be perhaps cluster analysis. If you want to predict, then maybe you use regression. If you want to classify different patients into disease 1, disease 2, disease 3, or healthy, then you might want to use classification and so on. Okay, so just a quick overview of the types of different models that you might use in data science. Associations is when you have, for example, when customer 1 buys a hammer, they'll also typically buy a nail or nails, because those tools kind of go together very well. So these are associations. Classification is if you want to predict the class or the label of an item. So let's say you want to let's say you have a list of ingredients and you want to be able to identify if a recipe belongs to a particular cuisine. And you want to label each of these recipes with its appropriate country. So is it Japanese, is it Chinese, is it Taiwanese, Korean, and so on. So that's classification. For prediction, of course, if you want to predict perhaps or forecast the potential value or something from some historical data, then you would use something like regression or SVM or KNN. For clustering, as I mentioned before, if you want to find clusters of different groups of people, clusters of people or groups of people, like in a hospital setting. There's also sequence mining. So instead of having just static data, you have kind of stream data or time-based data. And this could be something like a clickstream. When you're online, you're clicking from one point to another point. And sometimes you'd be using Markov models or HMM. If you have too many dimensions, if you have too many variables, so let's say we want to analyze photos, we want to analyze images, Now we can take each image and process it by converting each pixel into a number. So convert for each image, image number 1, we have pixel 0, pixel 1, pixel 2, pixel 3, and so on. So you can imagine there's, in a 400 by 400 image, you could have 16,000 or 160,000 columns of data, and you have multiple images, then you have just way too many columns to deal with. Now, one way to deal with this is to reduce the number of columns using dimension reduction or dimensionality reduction techniques. And one of them is called PCA, or Principal Components Analysis. Okay? Of course, you want to be able to visualize your data. This is not really an algorithm or a model, but you want to visualize to understand your data better. Because humans, we're very visual. Right? We like to see stuff. We like to see graphs or images. Of course, summary as well, under exploratory data analysis. If you want to look for outliers, if you want to look for linkages between different nodes or entities. So this is to find the relationships. You would use graph analysis. Okay? So today I'll be talking about hopefully 3 different demos, depending on how quickly I can go through them. Number 1 is Spark by Spark and Weather. So this is just kind of looking at it through exploratory data analysis. Number 2 after this is Spark and Weather with MLlib. So we're using the k-means clustering algorithm in Spark. And then finally, if there's time, I hope there is, but also to look at classification. So how to use R to create classification trees to predict which country a recipe belongs to. So if it contains soy sauce, if it contains noodles, if it contains or a bit of rice, or a bit of vinegar, red vinegar, maybe it's Chinese. So how can you create a model to predict what country it belongs to? Okay, so those are the 3 different demos I hope to be able to present today, depending on how much time there is. Okay. So to demo this, I'd like to go to Data Scientist Workbench. We've prepared a tutorial, more of an outline of everything, so it includes all the code and the documentation. This is a very, very long notebook. If you look at the side here, it's enormously long. So I'll try to go through this relatively quickly, and I'll try to see if you guys find it's easy to follow or hard to follow. Please let me know. I'll go through a little bit of code and do more demos. Okay, so less code, more demos. But if you want more code, maybe we can do some more events in the future. Is there a question?
Sorry, just a question to your previous slide. Right?
Yes.
Also, we have a situation so that the business don't really know what you guys are capable of.
Yes.
You can do many things with the data, right?
Mm-hmm.
So when they were asking to what can you do for me, they don't really have any assumptions or hypotheses.
Right.
But then if they just give the data, and the possibility for you to come up with the data is numerous.
Yes, definitely.
How do you bridge these two so that you can?
Well, I feel there's a yeah, that's right. I think there's an insufficient understanding of all these different types of methods to analyze and gain insight from data. Because, like hundreds of years ago, there's a concept of alchemy, trying to turn coal or whatever, copper into gold. In today's age, it's data, and trying to turn data into that kind of treasure trove of insight. But there's insufficient understanding amongst a lot of business managers today, I think, as to how we can actually turn data into this insight. And I think the best way to answer that is, we're trying to address that in Big Data University. We realize that this is a problem. A lot of business managers need to understand a little bit more about what is big data, what is it all about, what does it mean to be able to analyze data, why do you need a data scientist? And we're going to be creating a course on data mining algorithms. We've had a meetup. I don't know if you've attended, anyone here has attended, but we've had a meetup on data mining algorithms where we go through cluster analysis, we go through regression, we go through dimension reduction, and we also go through regression or classification. But we go through this at a very, very high level. So we don't really go into the code too much. We only go to the high level kind of concepts. And the goal is to kind of share with you an understanding of how to actually, how models and how machine learning helps the business gain insight from data. It's difficult to answer without teaching a lot of these models, I think. And I think the first step is for managers to be interested or to read into a little bit more about exactly what kind of data analysis techniques there are out there. Not just sums, not just counts, not just averages. It's a lot of stuff. There's a lot more models beyond that, I think. Okay? Great. Okay, so we'll go into the tutorial now. And this tutorial focuses on Spark SQL data frames. So for those of you who may have heard of Spark, you know there's RDDs. RDDs are the core components of Spark. So it's all kind of broken down into RDDs, but RDDs are kind of like if you read in a text file, each row can be considered. So you can have an RDD of this text, and it's very difficult to work with because it's not a table. It's almost unstructured. It's like a list. Okay. So instead, they've created something called Spark SQL data frames, and data frames are like tables. So if you're from a database background, these are exactly like tables. They're 2 dimensions. You have columns. You have columns and you have rows. Okay, and then you can have as many rows, as many columns as you want. But of course, when it comes to big data, you have many rows or many columns, and that's the only difference between maybe Spark data frames and a typical small data frame. Okay. So let me just skip down here to Spark SQL data frames, and